In 9.3, we are going to look at two functions, m and n, and we are going to describe the end behavior for function m, which is right here, and function n. So I already I already graphed these two functions into Desmos, and that's why you see these two graphs over here. So you could probably already guess just by looking at the end behaviors that this red graph is going to be an odd degree because the ends are going in opposite directions. And this green graph polynomial is an even degree because the ends are going in the same direction. So this is the graph of m of x, so negative x to the third minus 2x plus 8, and then this is the graph of n of x. We'll keep this in green. So n of x is equal to negative 20x squared plus 3x plus 8. So we're just going to describe the end behavior. So I want to know, I'm focusing solely on the end behaviors. So here's the end of this graph, and here's the end of this graph. So remember in 9.2, we want to look at the quadrant that these end behaviors are falling in. So on this odd degree, this end behavior is falling into quadrant 4 and quadrant 2. So as x is getting large, remember quadrant 4 has positive x values and negative y values, or positive inputs and negative outputs. And quadrant 2 has negative inputs and positive outputs. So as x is getting larger and larger in the positive direction, positive x, the outputs are getting larger and larger in the negative direction. And as x is getting larger and larger in the negative direction, so negative x, so that the outputs are getting larger and larger in the positive direction. So for function m, so m of x, we are going to say that as x gets larger in the positive, the outputs get larger in the negative direction. And then, of course, we're going to have to flip that for the other part of the end. So as x gets larger in the negative direction, your outputs, you could even just say y, the y values get larger in the positive direction. So that's just for m of x. Now n of x is actually a little bit simpler to write because our end behavior gets to go in the same direction. So this end over here, so we'll zoom into this graph. So this end on the right here is ending in quadrant 4. And this has a positive comma negative. And this is ending in quadrant 3, which is a negative comma negative. So I'm going to write the end direction, end behavior over here for n of x, just because I don't have room over there. So as x gets larger in the positive direction, so positive x, your y is getting larger and larger in the negative direction. And then as x gets larger in the negative direction, your y is still doing the same thing. Your y is getting larger in the negative. So what we can say for n of x is as x gets larger in either direction, the y values get larger in the negative direction. Sometimes it's just helpful. I really like to use the values of the points in the coordinate grid to help me do my end behavior. All right, now for number 2, they want to know for x is greater than 0, so number is bigger than 0, which function do you think has a greater value? Greater value is another way of saying greater outputs. So be prepared to share the reasoning with the class. So I think table of values are really helpful for this. So I'm going to make a 3-column table. I'm going to put x here. We're going to put 0 as one of the input values. And we want bigger than 0. So let's go 10. Let's go 20. Let's go 50. And then let's get really big. Let me erase that. And let's look at 100. And 100. And let's compare the two functions. Let's compare m of x and n of x. We'll do 2 different colors just to... So n of x. So believe it or not, on Desmos, you can actually calculate inputs and outputs. So I'm going to bring you over to Desmos and I'll show you what's happening graphically. So here are our 2 graphs. I've already graphed them for you. Here's x is 0. And what we really are concerned with is everybody who's bigger than 0. So everybody going towards the right. So the cool part is you'll notice that they're actually the same value at 0, 0, which makes sense because the constant for both functions is 8. So I'll come back over here and I'm going to write down what's going on. They're actually equal. So they're both 8s at 0 and 0. So they're actually equal to each other. Now let's look at 10. So this is how you get inputs for your functions. You want to click that gear icon, click on the table of values. It's going to start generating ones for you. So we need to get in there and fix those. It only generates a certain amount of input values. It's not like your calculator. So I'm going to change this to 0. And gives me 8. Awesome. I wanted to look at 10. What's happening at 20, what's happening at 50, and what's happening at 100. And I want to do that for both of these graphs because I want to compare. So at 0, at 10, at 20, 50, and 100. So if you look at 10, the degree 3 is negative 1,000, roughly negative 1,000. If you look at 10 for the degree 2 or the quadratic, it's almost negative 2,000. So our degree 3 is actually greater than that quadratic at 10 because negative 2,000 is a smaller number than negative 1,000. So I'm going to go back over to here and I'm going to go ahead. M of x was our negative x to the third, right? And n of x was our negative 20x squared. So we actually, the degree 3 was bigger. So this was bigger. And this output was smaller. Now let's look at 20. At 20, the degree 3 is negative 8,000. At 20, the squared is negative 7,932. So that's actually, the degree 2 is now bigger than the degree 3 because negative 8,000 is a smaller number compared to negative 7,932. So this now becomes a bigger compared to that. Let's look at 50. You're really going to start seeing the difference here. We've jumped to 50, and our degree 3 is at negative 125,000, roughly. This is only, the degree 2 is only at negative 50,000. So now you really start to see that the degree 2 is the bigger one, and that this one's the smaller output value. And at 100, this means it has 6 zeros. You're timesing it by 1 with 6 zeros. What's that? 100,000? 1, 2, 3, 4, 5. That's million, right? So this one is only at negative 200,000. So this is still a bigger or a greater output value than this one. This guy is so tiny at 100. Sorry, it's a little messy because I'm writing on the screen like this. So it's kind of cool to see if you were to kind of scale Desmos so you can really see that the degree 3 definitely has bigger values to start off. But at some point, that degree 2 is taking off and going to keep scaling the y. Oh, there it is. So that degree 3 has greater values to start off, but eventually the degree 2, that quadratic, somewhere around the x is 20, the input of 20, the degree 2 now has the larger values. So now you kind of have an idea of what's happening in this graph when you start looking at the values of x as it keeps getting larger and larger and larger.